I'm gonna start. Okay. Thank you very much, Nadia, for the kind invitation. Yes, as you mentioned in the introduction, I'm going to present the work that we do in Ground Lab, which is basically a sort of research lab, no, that is working within the Architectural Association. And I call this landscape practices in the capital scene, because there are certain types of projects, there are certain types of roles that I think landscape-oriented designers could have, no, in this moment, let's say, in history. And what Ground Lab is intending to do is to serve as a sort of model of this kind of practices, no, and the type of work they can do today. So I'm presenting this through the idea that there might be a number of research lines, no, that we are following as a office of design, no. Some policies are more, sorry, some more projects are related to ideas about how to implement certain types of policies, which I will explain through some examples. Some others are projects that tries to amplify the work of other people that could actually be other landscape designers, but also other communities. And also perhaps as well ideas on, you know, how to represent, to map and visualize, no, some of the effects of certain things that are happening, such as climate change, immigration, etc. And so urban age discourses have been or have had a detrimental effect on climate crisis through the implementation of city center policies and greenwashed in sustainability strategies. So these policies are the result of the economic system that dominates the world today, which is capitalism, and they are complicit in advancing and supporting the system as it is today. In doing so, they veil global productive hinterlands and capitalist and exploitative global north-south relationships, which are responsible for the environmental breakdown that we are living today. For example, some of the most lauded projects, such as the High Line in New York, have been linked to practices and policies of deforestation, which, for example, has been documented by Jane Hutton, no, in her book Reciprocal Landscapes. And projects that depicts as the future green sustainable projects usually veils the productive landscapes necessary for such ideas and projects to function. So the proliferation of industrial landscapes that force workers to continue supplying cities even when health crises such as the COVID or environmental catastrophes such as wildfires are present, such as the image I show in the lower right-hand side. They depict, no, these landscapes that usually are veiled with some of these projects. So in this regard, I'm going to show you projects that tries to reveal, no, some of the global perspectives of some of these aspects of some of these crises that we think the system in which we live are causing. So one of them is a project, it's called Inmigrando, which is basically a research that we did together with the Inter-American Development Bank. And this was a project to visualize processes of migration, planetary processes of migration, but also more specifically related to the region of Latin America. So as I said, this was commissioned for a cartographic research on the causes of migration for a larger project that included adaptation strategies in cities. And in here, for example, you can see in red the countries that basically from where people are mostly migrated in the planet, as opposed to blue, which are the cities that are being or receiving, no, some of this migration. This is obviously just generic representation of that, but we did also some of the causes behind that migration. So, for example, one of the reasons is the emission of carbon. And in here you can see the how the planet is foreseen to be heated, no, because of aspects of climate change. But this is in relation to the amount of carbon, no, that is being emitted. So this obviously is starting to produce some of the things that we're seeing in this cartography, which is the rise in sea level. And what this cartography reflects is the number of cities that are being affected, mostly of them coastal cities, and also uses information from the UN, where there's a projection where about 340 millions could be affected by 2050 and 630 millions would be affected if the situation continues by 2100. So this cartographic project then not only tries to explain in planetary terms what's happening, no, in terms of migration and what are the causes, etc., that are happening, but that will cause them, but also in relation to the region of Latin America. And we develop a number of maps, no, that describes some of the conditions, for example, in this case of land deterioration, no, the erosion of soils, which is what this cartography is depicting. There's also a number of maps that we did in this project that describes some of the social aspects, no, that influence as well some of the migration patterns. In this case, is levels of education that are seen from red to white, from the worst to the best levels of education that exist in the region. There's as well aspects about water depletion and how this water depletion is being affecting several numbers of regions across the continent. No? So in here, for example, you see from the red to the bluish what are the driest or the most areas that are affected by levels of water scarcity. We did that to start correlating, no, some of these aspects with the reasons why people were migrating in a number of different areas. There was a project, a photographic project that accompanied this project, which you can see some images in here, no, along some of the routes of this migration. And then we did also the routes or the origins and destinations of these migrations, no, that were described from, especially internally within the region. Some of the aspects, for example, that we use was a lot of UN data and obviously data from the World Bank, but a lot of the data didn't reflect contemporary trends. Like, for example, the sanctions that are being imposed in Venezuela were not really part of the data set that we received when we produced this. So we rely a lot on the use of scrapping Facebook data to understand the location of people across a period of time. And this was then reflected in, for example, in this diagram, where the migration from Venezuela was one of the highest at the point where we did this atlas. And so this was starting to reflect more the reality, not only coming from official institutions, but also from social network. And then we did some more in detail mapping, no, of the impact of migration per country, no? Like, for example, this is the case of Chile, where we highlight areas or regions where more migration is being settling, no, across the sorry, the country of Chile. So this was a project that we did, as I mentioned, with the Inter-American Development Bank, basically to map, no, the process of migration through the region. And this is a publication that it's available, online available, if you want to have further knowledge into this. Continues, because this is a open line of research that we have with the bank, was the development of what we call an atlas of climate risks and vulnerability, which this was done in the first instance in Argentina. And in this one, it's basically we're trying to map uh, how the movement, no, of water from a specific neighborhood in Corrientes, which was the main area of study in Argentina, could actually affect, no, a number of different scales throughout its movement. We can see this in the map in itself, sorry, in the atlas in itself, where we describe some of the aspects that we thought are important, no? Like, again, the conditions of vulnerable populations that exist. We did a number of maps that describes this across the region. Again, aspects about water depletion, aspects about deforestation, aspects about concentration of informal settlements, and what is the relationship between the location of these informal settlements and the deterioration of the ecosystems, which is, for example, the map that you're seeing right now. No? So there is a correlation of the settlement of these informal settlements with the damage that landscapes have suffered. And so normally these informal settlements are located in very vulnerable zones, no, that are prone to a number of different aspects, flooding, um, uh, even wildfires, etc. No? So this is something that the atlas is intended to describe, and describe it in a range of different scales in order for the governments in Argentina to take some of the actions and basically um, perhaps implement projects or policies that could protect some of these informal settlements. We also did a number of sections to describe basic ideas about what these projects could look like. Like, for example, in here, for example, there is a description of a typical informal settlement, no, in one of these areas, describing the basic infrastructure that it has, no, which you can see obviously in terms of pipes, pavement, mostly mobility infrastructure used for cars, no? And how this basic infrastructure could be transformed if you introduce some basic green infrastructure ideas, no? Such as afforestation of the pathways, reduction of cars, introduction of other mobility aspects, but as well as introducing sustainable urban drainage systems, etc., to improve microclimates, no? In both in summers, in a kind of non-rainy season, in a rainy season, to start demonstrating, how the atlas that could, in the first hand, read the problems or the areas that are in more need for these infrastructures to be implemented, and the type of infrastructure or interventions that you can do, no? So we did a series of these in a variety of urban landscapes, no? Such as this one, for example. This is the transformation of a park, no? That could be used in both seasons, but can benefit, no, by just let's say simple interventions that this policy could actually be helped to implement. Then we did a basic visualization of the city of Corrientes, which is surrounded by many of these informal settlements, and the necessity for a larger green infrastructure to be implemented as a network, no, throughout the city. This was part of a publication also by the Inter-American Development Bank, which is called Ecological Design. And here's where some of these ideas were collected as part of this publication. Another project that we did along these lines was the Atlas of Climate Risk and Vulnerability, that's similar to the one in Argentina. This was located in Chile, where the conditions of the informal settlements are seen in, exemplifying some of these pictures. And the information that we collected in the previous atlas, in the one of immigration, was used as part of introducing, where are the areas where most of the informal settlements are located, in which regions, etc., and what are the risks to which they are most affected by, no? Like in terms of, for example, flooding or wildfires or any other thing. No, we also did another analysis of the type of housing in which these informal settlements are, or what type of housing they live in. No, so to fall into what they call informal settlements. We did also some studies on in terms of the demography, the type of families, and how this is located in the area. So this was all about visualizing some of the services that the government have, the type of services that they are equipped, if they have any of these services. And finally, this was the type of map that we produced that in principle, this is information that the government of Chile uses right now to assess the priority of certain type of infrastructure, no, that can be or that would need to be implemented, no, because obviously there's a number of regions across Chile that requires this type of infrastructure, but what they need is some kind of hierarchy to understand where to act first because of the level of vulnerability that these settlements would have. So what you see, for example, in this map is one of the regions in Chile, the region of Biobío, in the city of Coronel. And you see in different colors, no, from purple to pink, different types of threats, which settlements which are marked in black are basically facing. And we did a sort of index that basically correlate the amount of these threats, no, that they are surrounded with, to in order to create a number that you see on top of each of the settlements to tell you which one is the one that is in more danger, no, is in more risk. So this will give the government, a decision-making tool to basically say, well, this one, for example, that has 5.2 index of risk could actually be our priority in this community to intervene, no, with some of the infrastructure ideas that we gave in the previous project. This one is an example in another region. No, this is the region of Antofagasta, in the city of Antofagasta. You can see in black again the informal settlements. These are all settlements that the government of Chile basically surveys, so they are official informal settlements. And then you can see obviously the region of different risks. No, some of them, for example, the pink one is movement of Earth that may be producing, I forgot the name in English now, but it's basically when it rains a lot, no, and it brings a big amount of Earth, it displaces, no, the soil, and obviously the informal settlements are at risk. So again, you can see the numbers at the top, no, that shows which ones of these are in more risk, and so which one will require first intervention. No, similar here, you can see the region of Valparaíso, and the same data applicable. No, so we did this in 3D rather than top view, so the people can actually also understand, in the geographic context, the geographical features. Understand the context in terms of the sea, the main infrastructure, etc. So it's more visually attractive, but also more visually understandable and easy to be implemented. No? So this is the type of projects that we've been developing in order to visualize, no, some of the problems that we are facing today, in the whole world, but especially in the region of Latin America. But what could be the type of visualization that could help certain public authorities, in this case governments in South America, to take decisions of what kind of green infrastructure. No? So I think this is a type of work that landscape designers, landscape-oriented practices could develop, and this is what we've been doing in the last few years. No? And these are questions for you. No? Let's say that if you were to do, or if you are doing in your own projects, no, like if you ask these questions for yourselves, no, which is some of the questions that we ask for ourselves as Ground Lab, like for example, what would be the global dimensions of your project, no? Not only looking at, what's the dimensions of your project within the boundary of your project in itself, but what would be the impact they might have at a global scale. What are the productive hinterlands on which they depend upon, no? Like, where are the materials that you are intending to use in your project coming from? Where are the landscapes and how they've been used or abused, let's say, in order to provide food, water, and materials, no? So this is something that perhaps you can think about that. and where are the materials coming from and the labor involved in them. No? So these are things that obviously not everybody would be able to answer them, but some of these questions can be answered by the production of atlases or cartographies that reveal some of these landscapes. And as I said, this is something that we're doing as part of a ground. Then is the question of policy design. Now, once we think, okay, well, it's important to visualize, it's important to show, the impact of climate change, the impact of migratory patterns because of several political or social conflicts. What can we do as well as, with the skills of designers? And this is something that we've been asking ourselves a lot. And we come up with this idea, well, not not something new, let's say, but we want to be involved, in the idea of designing policies. This is something that came out of the project we did in Santiago. Now, this is a competition we won some years ago, like 8 years ago, I think, to develop or to design a main avenue in Santiago de Chile, which you can see in this image. It's a 12-kilometer avenue, which is very important in Santiago de Chile. This is a competition, a design competition that we won at the time. And it's a very important one because it crosses many important landmarks across the city in Santiago, no? The presidential palace, the kind of squares and places where people go and celebrate or to protest the government. It has a historical development, which is also very important. It was a promenade for high classes a long time ago, but it was introduced with cars and the underground, and now it suffered from a lot of traffic, and that's why they decided to do this design competition. We did this competition with a number of, green principles, trying to incorporate a lot of the trees, no, that were the origins of this avenue, create new microclimates, increment or make bigger the pavements of this avenue so there's more space for pedestrian and more public transport, etc. These are the panels with which we won the competition, no? That describes the combination of public transport mode and the use of water as a main feature to not only irrigate the new plants that we wanted to bring in, but also to create public spaces, etc. No? So we won this competition, which with a number of, some of these images that reflects how we envisage the transformation of that avenue. So I'm just gonna flick through these images, of what is the idea that we had for the avenue, but something that happened along the way, and right now this project stopped because some of the aspects that we became very interested in is why some competition, especially at this large scale, are not able, let's say, to be successful, at least in our case. And this was, in our understanding, because of some of the policies that existed or that exist in Santiago that doesn't allow certain things. Like, for example, there's a policy in here in this avenue that you have to design the streets in a way that they can allow cars to travel at least at the speed of 80 kilometers. And so our proposal included, as you can see, for example, a lot of pedestrian crossings, a lot of changing of pavement for pedestrians to be part of, and all of these things were in the end rejected because they have to follow that policy. Like there's certain rules that you have to follow in order for your project to be successful in what they call social rent. And our project wasn't successful because we didn't comply with those things. So this was frustrating in many sense because of what this diagram that I'm showing in the screen reflects, which is the power that we have as designers, let's say, in order to influence the transformation of the built environment. Which I think is, in some cases, well, it's very little, because this diagram shows from left to right the decision-making process for the development of any given project, at least here in London. And so you can see, for example, that the first step for any project to happen is that the central government has to say what is needed. Then there's a London plan, for example, if the project is going to happen in London, to say how much of it needs is required. Then there's the local government local plan that would say what type of uses it would need. Then there's the land assembly, which would say where it is, no? And then there's the financial investor, which would say when it happens, etc., etc. So there's a number of steps, no, and a number of decisions that will happen until you finally arrive here at this point to the designers, no? That would design in general, well, how it should look, no? And so we think that we have also the certain capacities to, let's say, move upstream and try to place our skills and our abilities, no, to take some of the decisions before, some of these things could happen, because otherwise it could happen again. Well, what we did in Chile, no, that because the policy of allowing cars to go at speed. That is not possible even today because traffic jams doesn't allow that to happen. It stopped certain things to happen. So I think there should be a way in which we can actually influence the way policy are designed, and so other projects can actually happen. By the way, this is a diagram that we didn't do. This is a diagram that did by Finn Williams, which is an architect from London. But I think it's an important diagram that basically describes how much power we have, and perhaps I think it's important to understand that perhaps we can go earlier in these steps and join with other people, to try to make changes that are necessary for some of the ideas that are developed in schools of architecture or schools of landscapes to happen more quickly. So, for example, this is something that I will explain, in some of my lectures, is that the transformation of what you see in this image here in the left, as opposed to the right, is not related to a designer involved in that. No, you can see here there's a transformation with the small plots towards big land chunks of land. But this is a process that happens in many parts where designers are not involved, even though it has spatial consequences. In this case, for example, is the north of Spain, where you have agricultural practices, which requires a lot of water because they usually are incentivized to produce mostly monoculture, and they require water in a certain amount of the year, no, in a certain season. And the river that crosses wasn't enough, so they're basically building a new canal from the north of Spain to bring more water. But in order to pay for that, they just are giving water to those ones who has at least 5 hectares of land, and thus has produced, I mean, that specific policy has produced the transformation of this landscape into what you see here, no, like a consolidation of big land owners, which transform the landscapes and which design the landscape, no, which is something that I found so powerful, but without the power, let's say, that we hold as designers. This is another example in the Egypt, no, this is the delta of the Nile, sorry, and you can see this is the picture from the 1980s, and this is one recently from the last decade, where you can see the silting of this lake, no, and this is basically because of another policy, no, like the River Nile has been dammed, no, for a number of years, and the dams not only contain water, but they contain sediments, no, the sediments flow or are diverted to agricultural lands, no, together with the water, obviously, because the main purpose of the diversion of the dam is to irrigate agricultural land, but it also brings the sediments that is stopped, no? So you can see the erosion at the tip, so there's no more sediments arriving to feed, let's say, the delta, but also they are accumulated in here, no? So this is a design, no, that is not on purpose, let's say, but it's also part of a policy, no? And I think this is the kind of things that we can actually be part of or related into. So what can be the role of the designers in policy making and advocacy? So one of the things that we've done, for example, is this project in Mexico, which is called Socio-Hydraulic Resilience. This is basically a research project that we did with all these institutions over here. Like there's the British Geological Survey, there is the Center for Advanced Spatial Analysis in UCL, there's the university, Autonomous University in Mexico. No, so the idea of this project is basically that we produce a digital tool that allows Mexico City, on the one hand, to understand how vulnerable it is from water scarcity, and on the other hand, to read in the future how um, it can actually implement some what it's called eco technologies that allow them perhaps to reduce that vulnerability. No? So that's the purpose of this tool. What's the reason why we decided to do this tool? You may know that Mexico City is one of the cities that suffers from issues of water supply, water scarcity. There's a long history of the city. That started since the Spanish conquistadores came, to Mexico City to drain the lake on which the city of Mexico at a time called Tenochtitlan was founded upon, no? And that drainage of the lake continues to today, no? And today when you come to Mexico City, there's no lake, no? But basically the whole city is basically growing a kind of platform of asphalt and buildings on top of a former system of lakes, there were like 5 of them. And because of that, it extracts a lot of its water from the aquifer. No, 60% of the water that Mexico City requires, it's coming from the aquifer. And then 40% is coming from other basins, which are located hundreds of kilometers away from Mexico City, but also they are in lower altitudes. No, Mexico City is 2,200 meters above sea level. And if you bring sorry, the water from hundreds of kilometers, obviously you will spend a lot of energy, pumping that amount of water. But also, the way Mexico City is organized is that all the water that is used, including rain, it just goes away very quickly through the tunnel. That's the image you see at the bottom, which basically takes out the water from the city. And this has caused many things, like the sinking of the city because the aquifer is coming from the underground, so water is being reduced the amount, and so the city is sinking, but also it is spending a lot of energy to bring water from a lot of the basins that are in the surrounding areas, but also pumping out water, to get rid of it. So that's why you have images like this, where there's a lot of people suffering of water scarcity, especially poor people, because obviously the inequality is very uneven. Um, and that's the purpose, let's say, of this tool, to basically read, the levels of stress that the city has, depending on the location, no? So obviously, areas that are richer will have less stress because they have access to more infrastructure, but also people will have more money to access some of this infrastructure, but at the same time, they will be more educated and perhaps more willing to protest or, ensure now that they have access, as opposed to other regions in Mexico City. And that's how we came up with the index. We compiled a number of different data sets. And what you see here is basically a map, that shows levels of vulnerability. The red ones are regions municipalities, in Mexico City, which are more prone, to water vulnerability than others, And that's again similar to the atlas we did in Latin America, gives the government certain priorities, understanding which areas are more affected, not only because of the environmental reasons, but also because of social environmental aspects. We test this tool using one specific eco technology. In this case, it's a individual wetland, which basically is the idea that you may be able to build a wetland that could cater for the necessities of specific buildings, no? And so this is a prototype that the University in Mexico produced. And what we did in the tool was basically to try and test and say, okay, what would happen if all the houses in Mexico would have this type of technology? How much this would reduce, the vulnerability? And so, in this map, it shows somehow the reduction of the vulnerability. Like it's not very visible, because in order to reduce the water vulnerability of Mexico City, you would require not only that technology, but you would require many other technologies to work together, like, for example, water harvesting, or the introduction of massive wetland systems, to cater for larger infrastructure. But at least in this tool, it starts showing some percentages of reduction of the vulnerability that the city would have if you would introduce these individual wetlands. The same would go for the way in which they can be implemented if there were money. So we did not only the areas that would require personally the most of them, or if you have certain amount of money, you would have to select the areas where you would implement them first, but also we measure as well what would be the benefits, no, that they could bring in order to for the authorities to convince them. No? So there was, not only the population that would be impacted by the benefits of such an technology, but also the amount of water that could be filtered, the amount of jobs that it will bring, maintenance and manufacturers, etc. Um, I don't know if you can hear the sound. Let
A
me know if you
little
don't hear
bit,
the
a little
sound.
bit, yeah.
Okay.
Measure the impact of these solutions. Socio-hydrological resilience model evaluates the vulnerability of the city from different perspectives according to the criteria of various stakeholders. In a current scenario, and according to the increasing pressures due to climate change in the future for the year 2050. Was visualizing the areas with the highest risk to prioritize green infrastructure interventions. The model uses constructed wetlands as prototypes to mitigate the vulnerability of Mexico City and distributes the wetlands across the city according to its vulnerability and viability, and according to different budget proposals, highlighting the specific benefits that constructed wetlands will have on the neighborhoods of the city, and using parameters that maximize their impacts on vulnerability. The model visualizes the urgency of the situation by comparing the impact of the wetlands if they're implemented in 2020 or much later, 2050, which shows a greater resilience with a short-term implementation, especially in the most vulnerable areas. Designed as open source, the model has the flexibility to include new resilient green infrastructure solutions, include the voices of other stakeholders, experts, and communities in the scenario, and adapt databases and parameters for the city of Mexico or to the context of other cities.
So you can visit the tool and play around, no, like to see how it works. This is the link to it. So basically, what we're saying at the end of the video is that the idea is that you can produce a similar tool in other cities in order to measure water vulnerability, but also in order to help authorities, to take decisions on which would be beneficial and which ones you can implement first. And that's what we're doing now in Oaxaca, which I'm aware of the time, so I'm just gonna skip through it very quickly, which is another city south of Mexico. And what is interesting about this one is that, it's very similar conditions to the ones I described in Mexico City, just that the city in itself is a lot smaller. No, instead of having more than 20 million people, this has a million people. So there may be some interesting chances to impact more quickly, no, into the sort of reduction of vulnerability. So this is the city from a drone view, no, around. You can see the valleys that surround them. You can see the density. And something that we are doing right now, this is not a finished project, but it's basically the translation of the project we did in Mexico City in Oaxaca, is trying to use existing technologies that already exist in Oaxaca but are not part of a policy, which basically means they are not generalized as a solution for the city. This is, for example, a small kindergarten that exists in Oaxaca that uses water harvesting. So all water that requires the kindergarten is coming from this roof, and it's stored in a series of tanks that are filtered. And basically, this small facility doesn't require any connection to the outside world, let's say. No, it doesn't require to the infrastructure of water. Neither they require connection to the sewage, no, because they have dry toilets. And so this is a technology that already exists, but it's not generalized in the whole city. And we trying to incorporate this as part of the tool to read what would be the impact if all facilities such as these ones, such as public schools, kindergartens, etc., or perhaps even universities or hospitals would have similar things. What would be the reduction of vulnerability? This is something that it's already existing in Oaxaca, which is small dams, no, that collects water from the higher parts. You saw in the images, in the drone images, that Oaxaca is surrounded by mountains, no, and what happens is that there are no ways to collect water, no, that is coming from those higher parts, and the water just run and filtrates into the ground and is not used. Or the construction of these small dams will actually allow the storage of water and the distribution to a certain amount of locations that will be around these dams. No, so again, this is a sort of technology that exists, that is not generalized, that is just punctual. But what would happen if you would have something like this around Oaxaca? Or this one, which is under construction. This is going to be like an underground dam. Underground dam is a different type of technology than the one we saw in the previous one. It's, as the name says, is underground, and it's more efficient because it reduces the amount of evaporation. No? So at the moment they're building one example in Oaxaca City, and so we're trying to incorporate that again in the tool. And so if you incorporate water harvesting devices and collection of water from the higher parts, it will reflect a higher level of reduction, no, of vulnerability. There's also what is called the regeneration of certain ravines in Oaxaca. This is an example of it. You can see areas which are not regenerated in the outer parts of the picture, but in the center, there's a lot of regeneration. This could happen in many of the ravines across Oaxaca, no? Because as you may know, plants reduces the water speed, no? It allows water to flow very slow, to infiltrate the aquifer, and to allow, different types of plant, but also planting, no? In terracing, for example, will stop the erosion of soil, etc., etc. But this is a project that exists. And again, the idea is that we would like to reflect this into the tool, no? That we are building at the moment. Here, for example, there's a map that tells you the amount of water that you would be able to collect if you were able to build some of these dams that I show in the pictures across the whole of the valley, no, in the higher parts. And at the moment, the city of Oaxaca requires 1,000 liters per second. If you would do what I am showing right now, which is small dams all across the different ravines, this would provide 10,000 liters per second. So it's a lot more than what the city would require. And obviously, this will be reflected in the way the vulnerability would reduce, no? So yeah, I'm just gonna skip this part because this only shows some of the calculations that we're doing for the city, and some of the ways in which we are trying to collect as well social data, environmental data, ways to measure the index and the capacity of adaptation that the city would have, etc., etc. No? So all of these are studies that we're doing in order to create another tool for the city of Oaxaca, and to again lobby the public authorities, convince them that there is a way in which the implementation of these technologies could actually reduce enormously the levels of water stress that exist in the city. And finally, I'm going to jump this one, but I wanted to show you quickly what we did in Glasgow, which is the last example of what we can do in terms of policy as designers. This is a project we did with a think tank called Commonwealth, which is basically looking at ideas of how to implement Green New Deal policies. And we did an example on how to do that in Glasgow. In Glasgow, there was one of the COPs that happens in the previous year was in Glasgow, and in there we produced this website, no, that describes a number of ways and scenarios that could happen to Glasgow if some of the Green New Deal ideas would be implemented along the city. So we did basically three images. One that reflects the conditions of the housing in Glasgow, and we use a kind of inspiration from an image, Windows to the West, that is known by all the Glasgowians, because the housing estates in there are in very bad condition, like the social housing estates. And we thought like one of the policies that the Green New Deal is promoting is the retrofitting, no, of the housing. And so we took that as an example of what would happen if this social housing that it's been in the process of declining could actually be retrofit and invest and produce a different type of environment than what is happening right now. So this is something important because it is, it's this type of blocks, no, that exist across the city, and it makes up the urban fabric of the city. We did that with a number of partners, so you can see here the full network of them. So this was produced as part of a series of workshops. So the idea was that us were receiving ideas from all these partners from the city, from universities, from think tanks, from architects that have been working on retrofitting, and we produce images to imagine how this transformation would happen. So we start basically with a basic model of a social housing, like you can see here, and on the text you can see the comments, no, that people were giving us when producing these images. And so for us, this is a process of basically trying to build through images, through visuals, what a number of organizations are doing. And we serve as well more like a vehicle, no, to transmit and produce and create those features. And so what you're seeing in here is basically the way in which the image was evolving throughout these workshops and the way we have incorporated many of the ideas. And this is the final image that we produce. In here, we collected all the things that the workshops gave us as part of the information. So there was the implementation of the retrofitting that included central heating, but also the recovery of the central courtyards in places where you can introduce gathering for the community, but also workshops where you can fix your bicycle, but also laundry areas, areas where you can plant fruit trees, areas where you can gather, accessibility for elderly people, use of much as possible of the material that was on site so you can maintain the identity, use of water from the aquifer to access to give energy to the building, no? So this is more a compilation, no, of what you can do in all of this housing, social housing that exists in Glasgow, and what would they look like if you would do if you apply a policy of retrofitting, no? So here you can see more in detail, no, what's happening in this image, which is again a visualization of that policy. A similar thing we did at the scale of the street, no? So this is a typical street in that part of Glasgow with the social housing, and you can see there's mostly car driven. We transformed the street into a streetscape that incorporates green infrastructure, but it's also privileged pedestrians, bicycles, public transportation, electric cars for certain services, a lot of community commerce at the bottom. Huh? But again, this wasn't the result of our ideas. It was the result of the workshop that we implement. So you can see the same process that we undertook in order to develop these images. No? And finally, there's the same thing at the scale of the city. No? And there was a number of comments telling us, how problematic is the Clyde River that crosses the city, how it floods, the number of industrial sites that are abandoned, brownfields, etc. The way in which wind farms that exist in the surrounding areas could actually be part of the energy network of the city, how we can grow and use some of these industrial sites into incorporate them into the green infrastructure, and some of the blue lines and green lines that you see here growing in the city could be part of the cityscape that I show in the previous image. No, so these are all illustrations of how the policies could actually be visualized, no, to understand our role, no, as part of a decision-making process and not just providing specific projects. No, this is more like, well, this could be part of a general plan of Glasgow, and etc. We've done that in a number of cities in the UK, no? In Birmingham, and the idea is to do that in each one of the nations of the United Kingdom. And I'm gonna leave it there because otherwise there won't be time to perhaps some questions or comments. Thank you very much.